what are the different types of sources for particles, processes that are happening that can create them, both industrial and like weather related. And it actually, the activity in 3A, I'll talk about in a second, it's a little bit more of a build up on the same note cards that they just collected as well. So activities 2 and 3 are going to do kind of back to back as well. So basically the section talks about our particles come from a whole slew of sources in their area. We have combustion's perhaps one of the biggest sources, or a really big source of particles. So that not only means things like, you know, a forest fire, that kind of combustion, but also engine combustion, right? The emissions that we see from car and truck tailpipes, things like industrial processes, power plants, things like that, all that is combustion that gives off pollution. Wood-burning stoves as well, fireplaces. You know, it can get a little cool here. In the wintertime, some folks might have fireplaces, they'll see that. Depending on kind of the background of the students, where they're coming from, they may have, you know, family members that live in, you know, less wealthy areas. Maybe cook stoves in the house are things that are happening as well. And understanding emissions that can happen from cook stoves, things like grills in their backyard, all that is a source of particle pollution as well. I think in the past I've heard that folks found a lot of particle emissions outside of places like In-N-Out and Burger King, where they grill hamburgers and things like that, because it's open flame, cooking processes are happening. Lots of particles can come out of that as well.
Delicious particles.
Delicious particles. I mean, it could be that they are delicious particles, but particles nonetheless.
There are some local sources that may be worth talking about too, just briefly, because the port of Wainimi, which is not as big as the LA and Long Beach ports, but nonetheless is a major shipping port.
Right.
Those ships come in burning bunker fuel, which is a pretty dirty fuel, and they're doing a great job at the port at converting things once the ships get in to electricity at the port. They drop their emissions dramatically. There are very few major industrial sources in Ventura County, called Title V, but there is a large Title V facility here in Oxnard, which is Procter & Gamble, and they've got some extremely large gas turbines that are major polluters. And that because of the port, you've got all of the diesel trucks coming through the neighborhoods here in Oxnard.
Yep.
And so they would have those particles. And then the somewhat sort of unique focus are the particles related to agricultural production and pesticide spraying here in this county.
Also, there's an airport right next door, right? So you get airplanes coming through. That's another source of pollution as well. I don't know how busy of an airport that is, or the size of planes that come through, but still.
It's amazingly, it's small, but it's a towered airport, and it's a huge number of flights.
Yeah, just driving in here yesterday, I think in the little stretch on PCH that I was on, I saw like 3 different airplanes landing all within, 15 minutes or something like that.
They literally come right over that parking lot.
Yeah, the runways, yeah, it's right here, right at the end of the runway, so.
And they're pretty low at that point, so I'm sure if you left those monitors out, even the little particle collectors all day, it'd be good stuff.
Yeah.
Yeah, we have students walk around field trips, come over here, we're going to stand at the end of the runway and see what happens. On the other side of the fence, yeah, exactly.
Sure to come over.
So again, combustion, big source. Get to thinking about mechanical processes, so not only are the tailpipes of vehicles emitting, but brakes and tires wear down, and that produces a lot of particles as well. Paint flecks I mentioned before, but if there's a car accident on a road, not only are you getting the emissions of when the car was running, but now you've got paint chips and other things like that. Yes, I was just rear-ended on the highway last week, so that was awesome. And I was like, oh, nice little bits of particles over here. So how nice.
Thanks.
Luckily, we were going I was stopped. He was going 8 miles an hour, so it wasn't that bad, but it was annoying. Anyway, also another source, things that are weather-related or natural, just activities, things it's not really a problem in California, but volcanoes. our big source of particles, right? And there's, if you look in historical records, you can see when a big eruption happened, you know, how much SO2 was emitted into the air, and that's a white particle, and that causes cooling, and so whole global climate temperature dropped. You know, it can drop on years when there's really big volcanic eruptions and things like that. So not just at the local level, but you're talking, you know, globally as well. Impacts like volcanoes. Sea salt, I mean, the ocean's right here, right? Sea spray is definitely a source of particles as well. So I'd be curious to see if they take an airbeam down to the beach, if they see some particles. And then it's funny here, it mentions like de-icing roads. Not really a problem here in California. So, but road salt and things like that would also be a source of kind of everyday particle emissions that they may not be thinking of. A lot of the ones I mentioned are what we would call these primary sources, things like soot and metals, soil, dust, things like that, sea salt. But we also have, for the very small particles, they can, or just different kinds of organic aerosol, or things like ammonium nitrate or ammonium sulfate, things that happen also as well in kind of agricultural activities. From gases that are emitted from those processes as well, they can kind of react chemically over time and start to produce aerosols as well. That's kind of that secondary organic aerosol I was talking about. Comes from things like hydrocarbons and sulfur dioxide and other particles, or other gases in the air that then become particles as well. So gets them thinking about those sources. The book goes a little bit as well to think about how kind of the shape and the color of particles is indicative of the type of source. So we mentioned, again, things like pollen. You can see pollen, if it's on their note cards, can be different color, like yellow, greens, things like that. Oranges, any kind of colors. They're interesting shapes and sizes. Soot, things that from a combustion, like a big, you know, black plume of smoke you see coming out of a ship or an airplane or a truck or you know, a train, anything like that. That's black carbon emissions as well as diesel emissions. They tend to be very dark. They're going to be like black particles in nature. So if you see any of those on your cards, kind of indicative of that. Wood smoke in comparisons, things like a natural forest fire or some kind of other, you know, wood smoke that's happening is going to be something that's more gray. It's like a lighter color in nature. So that's kind of nice and easily distinguishable from things that are more like diesel or black carbon. It's a different kind of particle. So they're going to be, and not only that, I used to have these nice little filters with us, and they're not in this kit anymore. You can kind of smell wood smoke. So a lot of times we use these regulatory particle measurement techniques, and we collect particles on these big kind of filters. And I have a location up in San Rafael that I monitor. I keep track of particle emissions. It's outside of a rock quarry, so the folks are interested to know what kind of stuff they're breathing in, not just diesel from the trucks that are moving rocks around, from the rocks themselves, things like that. You can get metals and other things. But anyway, I have a particle collector out there, and one of the fires, I guess this would have, it's hard to keep track of which fire this was recently, but I think it was the big fire in Paradise last year. The smoke obviously very heavily impacted the Bay Area, and so where down the road in San Rafael, we collected one of these, and for several days in a row, we just got the thickest layers of smoke. These particle filters are run for about 24 hours, they'll collect, and you take it out and you can just smell it. I opened the chamber that it came out of, and I was like, whoa, it still smells like the fire is collected in there. So, if they are collecting particles on kind of filters, note cards or some of that, there's somewhere near something that's burning, that smell will tend to carry with it. And then lastly, kind of talks about dust particles being more kind of, brown most of the time. They're kind of more sand-like or rock-like in nature, kind of little bits of rocks. So all that's kind of the information that they can put in the activities, looking at their note cards and kind of saying, there's a section that asks them to do that. Can you draw or describe the particle a little bit better, where you collected it, and what kind of source you think it is based on just that appearance. So again, we talked about kind of particles moving around, coming from vehicles, factories, roadways. I was like, what is that sound?
Particles.
Particles, yeah, the particles, all particles. They get moved around depending on wind and weather conditions. And that's interesting because, you know, it talks a little bit about how that affects not only the air that they're breathing, but things that they may not think about, waterways. If there's a big lake somewhere, you got a lot of particle pollution, you know, that could be a problem. It could affect the air water exchange can lead to things. Storms, weather can bring pollution from other places, help transport it, bring it, you know, dump it down somewhere else. Can affect, basically the ecosystem impacts of particles are there too. Plants and trees and things like that can be affected also by not only particles but also like other things in bad air quality. Ozone, turns out ozone's super disruptive to plants and rubber and other things like that, which breaks things down, which can in turn create more particles as well. So it's a cycle, everything's linked together. So the section does a good job of kind of describing all of that information to give them some more of a background on that as well.
And I'll say one example is we for our air sampling, look at microplastic loads in the atmosphere. We started finding a lot of these little teeny black flecks that chemically come out to be what's called black carbon. So we thought it was soot at first, but we started looking into it, and there's some work from some colleagues up in San Francisco suggested it might, there's a good chunk of it that could be tire rubber, so particles from, so the way that we characterize it, it's not as it's a little bit less precise than some of the ways we can use. And so the suggestion is that what might be happening is there's so much tire abrasion out there, and there's so much tire dust that we now have this sort of potentially sort of consistent fog of tire dust around. And we don't think of that as a typical source, but all this stuff can become particles.
I mean, if just sheer number of vehicles on the roads,
Totally.
right? I mean, it's definitely, it makes sense in this state, probably more than a lot of other places. But I don't know the number of cars on the road. That's a quantity that can be known. So probably not hard to go, oh yeah, totally makes sense. So that's cool. There's a constant cloud of tire rubber that I'm breathing in every day. You'll learn something new.
Merry
every day.
Christmas.
So yeah, exactly. Can't wait to call my mom later and tell her that. So again, so I don't know if you guys noticed anything. What kind of stuff did you see in your index card? Did anybody actually see anything? Is there any kind of indication of